Welcome again for the second session, which will be a bit short because we'll be knocking off at 2:30 and we are left with about 25 minutes. So I want to take you some few geometric riders relating to grade 12, proportionality and similarity theorems. Thank you. Check the exercise that I'm going to do with you right now. 7.2. Look at the exercise. In the diagram below, triangle VRK, check triangle VRK, has P on VR, and T on VK, such that PT is parallel to RK. All the information clearly marked. VT is equal to 4 units. Here's VT is 4. PR is 9. PR is 9 units. TK is 6. TK is 6 units. And VP is equal to 2x minus 10 units. The first question, calculate the value of x. Calculate the value of x. Maybe I should take you through this one because I'm just welcoming you into grade 12. Into grade 12's work. So, proportionality theorem. Remember, the proportionality theorem states a line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. Let's check the solution for 7.2. VP over PR. I'm saying VP over PR. This will then be equals to VT over TK. VT over TK. Let's write down a reason for that statement. It's because it's a line parallel to a side of triangle. A line parallel to a side of a triangle. We know that a line parallel to a side of a triangle cuts the other two sides so as to divide them in the same proportion. Let's check VP. VP is 2x minus 10. Then you've got 2x minus 10 over PR is 9, which is equals to, check VT is 4 over TK is 6. Let's cross multiply. If we do the cross multiplication here, or we can simplify 4 divided by 6 here, we've got 2x minus 10 all over 9. This is the same as 2 over 3 because 2 is a common factor. Even here in 6, 2 goes 3 times. We can cross multiply. If we cross multiply, you've got 3 multiplied by x will give you 6x. 3 multiplied by 10 will give you minus 30. Then 9 multiplied by that 2 gives you positive 18. If we cross multiply here, 9 by 2, 18. 3 multiplied this, 2x gives you 6x. 3 multiplied by 10 gives you 30. Now, let's group the like terms. On the left-hand side, we are only left with 6x. We transpose this negative 30 to the right. Then we've got 18 plus 30, which will give you 48. Now it becomes easy for us to solve for x, because if we solve for x, we just divide by 6 both sides, and then we find that 48 divided by 6, then it will give you 8. Therefore, it means x is equal to 8 units. Then calculate the value of x. Therefore, here x is equal to 8 units. The only theorem that we applied here is the grade 12 theorem, which states a line parallel to a side of a triangle divides the other two sides in the same proportion. From there, we just carried on with the algebraic manipulation. That's why we got the value of x as 8. It wasn't difficult, and I hope you enjoyed it. So I'm going to give you an exercise based on the very same theorem. I want you to do it in 5 minutes' time. I'm going to give you 5 minutes to do a similar problem. Thank you. There we are. It's question 10 of 2011. Thank you. There we are. In the figure below, DE parallel to FG, parallel to BC, AD 36 centimeters, DF 24 centimeters, AE is equal to 48 centimeters, and the DE is equal to GC, and they are both equal to 40 centimeters. The question then states, determine with reasons the length of 10.1, e.g., for 2 marks. You need to determine the length of e.g. for 2 marks, and then determine the length of BC for 4 marks. I'm going to give you 5 minutes to work it out. And then after 5 minutes, I will then do it for you so that you can then check your work against mine. I hope you enjoyed this one and you also got it right. Good luck. Welcome, welcome, welcome everyone. Welcome everyone. I think you've enjoyed the first one. Now this is the second one on grade 12. The theorem, the proportionality theorem. Let's check. In the figure below, DE parallel to FG parallel to BC. All the information clearly indicated on the diagram. AD is 36, here is 36. DF 24, here is DF 24. AE is 48, here is AE 48. DE, whereas DE 40 and GC 40. So the first question then states for 2 marks, determine with the reasons the length of EG. The length of EG. Let's apply the theorem. Here is EG. Can I do this? You'll allow me to do this? I believe. There we are. There we are. Now you can see if I do that, we have triangle AFD where DE is parallel to FG. And we know that a line parallel to a side of a triangle divides the other 2 sides in the same proportion. Let's carry on. The question states EG. We want EG. Here is EG. You can say EG over 48. EG over 48 will then equal to 24 over 36. 24 over 36. Then you write down the reason for your statement. It's Euclidean geometry. Every statement must be accompanied by a reason. The reason here is a line parallel to a side of a triangle. A line parallel to a side of triangle. We know that a line parallel to a side of a triangle divides the other 2 sides in the same proportion. Then we just do our algebraic manipulation here to determine the length of EG. Therefore, you multiply both sides by 48. Therefore, EG will then be equal to, you multiply by 48 here, you've got EG, you multiply this one by 48. Let's check the answer. You work out the answer. 24, you divide it by 36. Nay. Then the answer you multiply by 48. I think the answer you get is 32. The EG will then be equal to 32 centimeters. 32 centimeters. Now we go to EG. This EG is equals to 32 centimeters. It is key, it is very much important to always indicate the given information on the diagram. Happy with 10.1? This was 10.1. Now let's look at 10.2. 10.2 then states, let's find the length of BC. 10.2, we are required to calculate the length of BC. Let's get on. How can we determine the length of BC? Remember, in grade 12 again, we have what we call the similarity theorem. Let me take 2 triangles. Check this bigger triangle, triangle ABC. I want us to work with those 2 triangles. Then I say in triangle ABC and triangle ADE. Look inside the 2 triangles. Triangle ABC and triangle ADE. I want us to prove similarity between the two triangles, this bigger triangle and the smaller triangle. And you know very well, to prove similarity between any two triangles, you just have to prove that two pairs of angles to be equal, and then the third pair, because they'll add up to 180 degrees, will automatically be equal. Thank you. We are busy with 10.2. This is 10.2. We are in triangle ABC and triangle ADE. In the two triangles, check, we've got angle A. This angle appears in triangle ADE. And again, this angle A appears in triangle ABC. So we say angle A is equals to angle A. It's common. It is common to the two triangles. Then, in triangle ABC, check angle B here. Angle B, check angle B here. Because this BC is parallel to DE. If I can simplify it, I can also say I've got D1 here and E1 there. Check the relationship between angle B and angle D1. Then I will say angle B is equals to angle D1. Those are the corresponding angles. Corresponding angles where DE is parallel to BC. See? Already we've got two pairs of angles. Check the remaining pair. In this two triangle, in triangle ABC, I've talked of angle A and angle B. The remaining angle here is C. In triangle ADC, I've talked of angle A and I've talked of angle D1. I haven't talked of angle E1. So it means angle C will be equal to E1 as well. Angle C will also be equal to angle E1. Why do I say they are equal? Because these are also the corresponding angles. Because those are also the corresponding angles where DE is parallel to BC. Therefore, it means the two triangles are equiangular. And if they are equiangular, then it means the two triangles are similar. Then we draw a conclusion that, triangle ABC will then be similar to triangle ADE. ADE. There is an angle. It's a geometry. We always provide a reason for our statement. I'm sorry for this lovely work, but here triangle ABC is similar to triangle ADE because we have proven above that the two triangles are equiangular. Angle, angle, angle.